Okay, so here's the video that is going to help you with the second half of the quiz for tomorrow. Um, the If you look at your worksheet, it's number 6 down here. Okay, like I said in the previous video, 1 through 5, and you should have worked through 1 through 5 already um, to before starting watching this video. All right, and then number 6 here. Now, obviously, I don't have the hand drawn version. Mine just shows this. Yours has the hand-drawn version, so you'll want to reference yours, not mine. Okay, but here's an example graph of what I'm talking about, and we're going to work our way through this. Okay, so what we've got here, or we've got a force versus time graph where we have 3 forces already graphed. We have A, B, and C. Well, if you remember on a force versus time graph, a force over any amount of time represents an impulse or a change in momentum. So we have 3 right now. We have impulse A, we have impulse B, and we have impulse C. Okay. Now, to find what the first thing we need to do is we need to find the values of these impulses. All right. And so to do that, we find the area under the curve. Okay, so for impulse A, it has 1 Newton of force. All right, so 1 Newton of force for 2 seconds. So its area would be 2 Newton seconds. So what I'm going to do is over here, I'm just going to go ahead and put 2 Newton seconds. And we're going to leave that there because it's going to be there for a while. Now, you know what? I should probably indicate that that is a positive 2 Newton seconds. So let's go ahead and do that. So impulse A is a positive 2 Newton seconds. Now, impulse B, let's go ahead and do the same thing. We need to find the area under the curve here. Well, it has negative 2, all right, for 2 seconds. And so negative 2 times 2 will be a negative 4 Newton seconds. And so for impulse B, we get negative 4 Newton seconds. And yes, impulse can be negative. Remember, that just means the force is pushing to the left instead of pushing to the right. So that is nothing new at this point. Impulse C, all right, we've got positive 2 newtons for a single second. And so that's 1 times 2. And we are going to get, again, a positive 2 Newton seconds. Now, because I'm kind of limited in how I drew these, these came out being the same. I don't always like using impulses with the same values. Usually I have one that's 3 or something else. Okay, so just be aware that right now, because I'm kind of limited on my touch screen here and I don't have my whiteboard in front of me that's not super easy to use, we use +2, -4, +2. Usually these two are not the same, but it is what it is. Okay, so that means that there's an impulse of positive 2 Newton seconds here, an impulse of -4 Newton seconds for B, and an impulse of positive 2 Newton seconds for C. Okay, now down here at the bottom, I have a given and some things I want you to find. All right. So this will be given to you, or there will be enough information given to you that you can figure out what the initial momentum is. For instance, if I gave you a mass and a velocity, a mass and an initial velocity, I would expect you to be able to use this equation right here, P equals m times v, and calculate the initial momentum. Okay. Now, what we are going to do here is we are going to find these momenta here. And I said momenta because that is the plural of momentum. Okay, so you're not mishearing me there. I did not say the M on the back because I'm using a different vocabulary word there. So momentum is singular, momenta is plural. All right. So what we are going to do here is, let's say, given the initial momentum, P naught, we're going to say that's 0. Okay. So if we're given this, now another way I could say this is the object is at rest, right? Now remember, momentum units, kilogram meters per second, and Newton seconds are the same thing. So I could write this the same way. Oops. Those two things are the same. Okay. So remember that Newton seconds and kilogram meters per second are the same units. They're equivalent. All right. So now what we're supposed to do is we're supposed to find the momentum at 4, the momentum at 8, and the final momentum, or that would be the momentum at 11. We could refer to it either way here. Now, so what do we know about that so far? So right now, the initial momentum is here, right? Before impulse A. The momentum at 4 would be the momentum here. The momentum at 8 would be the momentum here. And the final momentum, or P11, if I had 11 marked, it'd be at 11, or the final momentum is there, right? So we are trying to find initial momentum, momentum at 4, momentum at 8, final momentum, okay? Now, we have everything we need. We do not need any more information than what we're given right here. What you have to remember is that an impulse is the change in momentum. Okay? So if the momentum is here at 0, is 0 Newton seconds, and it undergoes an impulse of positive 2. That is the change in momentum. So the momentum was 0. It underwent a change of 2. What would its momentum be after that change? Well, the answer is 2. All right. So at 4 seconds, the momentum would be 2 kilogram meters per second, or 2 Newton seconds. All right. Because the initial momentum was 0, it underwent a change of positive 2, and so now its momentum is positive 2. Now, at 4, it's positive 2. All right, we've already undergone the change of A, so we don't need to worry about A anymore. Now we hit this impulse B. It's a negative impulse or a negative change in momentum. So if our value at 4, remember it's 2, and we undergo a change of negative 4, because that's the value of impulse B, then that our final value at 8 would be negative 2. So it would be negative 2 kilogram meters per second, or negative 2 Newton seconds. Again, why? Our value here is positive 2. It undergoes a change of negative 4. So positive 2, change it negative 4, so just subtract 4, makes it negative 2. Okay, so our value at 8 is now negative 2. All right. And it is going to undergo another change of momentum, this impulse here at C. All right. And its impulse, that's a change of positive 2. Again, I don't like that. I wish I had drawn it at 3 or something like that, but again, it's just positive 2. So if our value at 8 is negative 2 and we undergo a change of positive 2, that means our final momentum there, well, negative 2 plus 2 more is 0. So we're back to where we started on that one. All right. So I'm going to give you about 2 or 3 more where I change these givens. And what I'm going to want you to do is I'm going to give you the given here. All right. And then I'm going to have you find P4, P8, and the final momentum. Okay. And then while we're doing that, what you'll need to do is after I give you the given, I would like you to pause, figure out what these are, and then hit play, and then figure out if you got them right. Okay. So Let's say our initial momentum this time is, let's start with 5. 5 kilogram meters per second. Okay, so given that the initial momentum right here is 5 kilogram meters per second, find P4, P8, and the final momentum. Go ahead and hit pause now, figure that out, and then resume, and I'll go through the answers. All right, so here are the answers. If our initial momentum is 5 here and we undergo a change here, our value at 4 is going to be 7 kilogram meters per second. Then if we undergo a change here at B of -4, that means at 8, our value is going to be 3 kilogram meters per second because it went from 7, undergoes a change of -4 to get to 3. And then if we undergo a +2 to get here to the final momentum, we're back to where we started at 5. All right, so I really don't like the fact that I did this. So here's what I'm going to do. I'm going to change my graph real quick, and I'm going to add, right there, I'm going to add 3 momentum up there, or 3 newtons. So +3 newtons. I'm going to put it up there. And I'm going to change my impulse C here. I'm going to make it go up to, shoot, still got my arrow on. I need to turn my arrow off. Make it go up to 3. I'm going to call that about, yep, that's about 3 right there. Go over there and then come down. Okay, so what that's going to do now is that is going to change impulse C from +2 to a +3. And so now on this next given, things will be a little bit different. And so this is a little bit more what you'll see on a quiz or the test. So let's try this again. Again, after I give you the given, go ahead and hit pause and then figure out what the answers are. So I'm going to start this one. Let's go ahead and start this one with 3 kilogram meters per second. So go ahead and hit pause, figure out P4, P8, and final momentum. All right, so P4, if we start at 3 and undergo a change of 2 for that first impulse A, we're going to end up with 5 kilogram meters per second. If we then undergo a change of -4 for impulse B, we're going to go down to 1. And then if we have a change of +3 for that last impulse that I just changed, that would change our final momentum to 4. All right. All right, so I'm going to do one more practice. All right, and then after this practice, you'll want to work number 6 on that worksheet that I showed you in preparation for the quiz tomorrow. All right, so let's erase these and let's give you our final practice here. And I'm going to give you something weird. I'm going to start at -3. All right, there's no reason that the initial momentum has to be positive. It can be, the object can be moving to the left, and that's all that this is showing. So we've got some negative momentum here. Please calculate the momenta at 4, 8, and final. Go ahead and hit pause now, and then resume here in a second. All right, so if you have figured this out, if we are starting at -3 and we undergo a positive change of 2, -3 plus 2 will get us to 1. And so, or excuse me, -1. So it's a -1 is our momentum at 4. After 4, we undergo the impulse at B, which is a -4 change, if you remember. So that